All right, it's time. Welcome back. I hope you had a good break. I had a good break. We do have homework due tomorrow, so check it out. The homework involves drawing on some pictures. So if you were here last time, I printed them out and handed them out for everybody. If you weren't here last time, I got some extras that you can pick up at the end. Or, I mean, as usual, you can get it at the website. You're gonna have to print it out yourself if you don't get one of my printed ones. We are talking about gerrymandering, and some people were not here last time, and so I would like to refresh our memory a little bit. I'm gonna do a couple more examples of the type that we were doing last time. So this is all about gerrymandering. Gerrymandering is about drawing like geometric voting districts in order to achieve certain outcomes in the election. This sounds like an impossibly obscure and arcane subject, but it's actually super important in real life, and especially in American politics. Gerrymandering is super important. A typical example will look something like, how about this? I've got this on a handout that I'm about to give you, but the idea here is we have 64 squares, and 32 of them are light, 32 of them are dark. And you think of these as representing individual voters who like live in their houses or something. Now these are on a very rigid grid, which is not terribly not entirely realistic, but we're going to do some more non-grid-like ones also. You imagine that these are voters who are in like two different political parties, the dark ones and the light ones. And I drew this one so that there's an equal amount of both. But let's imagine that we want to divide them into districts. Let's make 4 districts of 16 voters each. Now, the voters themselves are evenly split between the two parties, but depending on how you divide up the districts, you can make it so that a different amount of districts are won by the lights versus the darks. We'll try it out. I have here a paper with many copies of the same picture, just because these problems will involve sort of drawing on top of these pictures. The whole idea of gerrymandering is to draw the districts in a weird way to make the outcomes happen in different ways. Okay, so I want to make 4 districts of 16 voters each. I'm going to do this by like circling some of the squares, and of course there are many possible ways that you could make 4 districts out of this, but maybe I will just invent some here at random. I need 16 voters each. All right, I could do, how about that's 16 voters, that block right there, and then maybe over here I will take 16 like that. I believe this is an 8 by 8 square, so that is also 16. And then maybe I'll take these 8 here plus those 8 and then these guys. All right, so there I made 4 different districts. I'm just making this up. And let's see if we have the people vote in these 4 groupings, who how many will be won by the darks versus how many will be won by the lights. Maybe I'll give them numbers. Let's say that's number 1, number 2 is there, 3 is there, and then number 4 is down there. And who's going to win in each of these? Well, we just have to count them up. So in number 1, I see how many darks versus lights. I see 1, 2, 3, 4, 5, 6, 7, 8, 9 darks, and 1, 2, 3, 4, 5, 6, 7 lights. So the darks win in district number 1. I hope I counted them properly. And so on. The other one, so district number 2 looks like 6 dark 6 dark, and all the rest are light, 10 light. So here the darks win district number 2 also. Number 3 is, I see 1, 2, 3, 4, 5, 6, 7, 8, 9 dark. Did I say the dark? Sorry, the lights win, right? 10 lights. I'm just seeing who gets the most each time. Okay, anyway, number 3 has 9 darks and 7 lights, so there the darks win. And number 4 has 1, 2, 3, 4, 5, 6, 7, 8. Is that right? 1, 2, 3, 4, 5, 6, 7, 8. 8 and 8. This is a tie. 8 dark, 8 light. This is a tie. All right. So with this, with these lines, these are called districts. With these particular districts, we get dark wins 2, light wins 1, and 1 tie. All right. This is the basic sort of thing that we're going to be do when we're talking about gerrymandering. And the 2 very basic questions that are actually the next 2 things on the big checklist as far as our topics for the semester are, first of all, which different outcomes are possible or impossible. For example, in this particular example, is it possible to draw the lines so that the D's win 3 and the lights win only 1? Is it possible to draw the line so that the D's win all of them? These are questions that we're going to be answering. Which different outcomes are possible or impossible? Here, like as a specific question, can the D's win them all? This kind of thing is what we need to think about. And then also the second question is, given once you've decided which ones are possible versus impossible, can you actually draw the ones which are possible? So can we draw all the possible ones? Right? And these are actually different questions. Like the first one, you might say, I asked specifically, can the D's win them all? You might say, yeah, it's possible for the D's to win them all. And then it's a separate matter to actually draw out the lines in such a way that the D's really do win them all. Those are really two different questions. All right? Which are possible versus impossible, and then can we actually draw all the possible ones? So let's try and talk about that for this particular example. I'll bring the picture back here. For this particular example, which are possible? This is a question that you can answer. Actually, you don't really need to look at the picture to answer this question, which are possible versus impossible. It's really all about the numbers of each person in the 2 parties. So we have 30. I said at the very beginning, we have 32 lights, 32 darks. And each district will have 16 voters in it. That's just, all of this I just told you at the beginning. Or if you don't, if I didn't tell you, you could count the dots if you like. Each district is going to have 16 voters. So, first of all, when we're thinking about which are possible, you should always base this on what I'm going to call the threshold to win each district is, can anybody say, if there's 16 voters in each district, how many do you need in order to win that district? Yeah? I would say 9. Yeah, if there's 16, then 8 would be a tie, which, I don't really want to talk about ties for the most part. I would just want to talk about winning. In order to win in each district, the threshold to win is 9, all right? So that's because 8 would be a tie. You need 9 to win, all right? This number, the threshold, is always just half of the number of voters plus 1, or maybe if the number of voters is odd, you would round it up. Okay, this is the threshold to win in each district is 9. Okay, so if I ask myself, I would like to ask myself questions like, can the D's win 3 districts? In the example that I did before, they won 2. The D's won 2 with a tie. Is it possible for them to actually win 3 of them? Well, you think of this in terms of the thresholds, all right? So when I ask myself, can the D's win 3 districts? You got to think, how many voters would that require? You need 9 voters to win a district. So it requires, can anybody say how many voters would you need to win 3 districts? 27. Yeah, you got to multiply here, right? You need 9 voters to win a district, so it requires 9 times 3, which is 27 voters to win 3 districts. All right? And do they actually have that many? Yes, they do. I said before, or you can count them if you like. They have 32 light voters in here. All right? It requires 27 in order to win 3 districts, and so they do have enough. So the D's can win 3 districts. All right? You can figure all of this out without really even looking at the picture. Like I said, it's a separate issue to actually draw the districts in a way that the D's win all 3. But this is how you reason about, can this or that group win this many? All right? What about, can the D's win all 4 districts? Can the D's win all 4? Again, you have to think about how many voters would be required in order for them to win all 4. You need 9 voters to win each district. So winning 4 districts requires 4 times 9, which is 36 voters. And so that is impossible. That's because the D's only have 32, right? Like I said at the very beginning. Or you could count them if you want. So D's have only 32. So the D's cannot win 4. All right? So it's possible for the D's to win 3 of them, but not all 4 of them. And this is because of the threshold. This is what you got to think about. The threshold. All right? Now, everything that I said about the D's here is actually the same also for the L's, the light ones, right? Because there are also 32 of the light ones. So similarly for the L's can win 3 but not 4. Because to win 3 requires 27 votes. The L's have 32, so they can do that. But to win 4 requires 36. They do not have that many, so they can't do that. So the L's can win 3, but not 4, all right? A typical question that I'm going to ask you, like on the homework or on our test about these kinds of things, would be, what are all the possible outcomes? So the possible outcomes would be, the D's cannot win all 4, but the D's can win 3. So I'm going to say this is 3D and 1L, right? That's one possible outcome if the D's win 3 of them and the L's win the other one. Another possible outcome would be if they each win 2. That's certainly possible. And then another possible outcome would be 1D and 3L. And that's it. You can't get 4 and 0 because like I said over there, the D's are not capable of winning all 4, and the L's also are not capable of winning all 4. So 4 and 0, or 0 and 4 are impossible, right? Because of everything that we said up there. All right, so this would typically, on our test or something, this would be maybe like part A. I would ask you which ones are actually possible, and which ones are not possible. This is how you figure it out. It's always reasoned according to the threshold to win, how many votes you need to win. All right? Now, what about actually drawing the districts? Now, this is much less of an exact science, and there is some amount of technique which you just have to sort of practice and get a feel for things, but I'm going to try to give some general advice here. Let's look at some techniques. Let's try to draw 3 Ds and 1 L, all right? Of course, there are many different ways you can do this, and if this was a real test question, I would expect you all to give me different answers because it involves drawing the lines in a very specific way. But I'm going to try to draw 3 Ds and 1 Ls. Now, the strategy that we're going to use, and this is the same strategy that people use in the real world to try to manipulate election outcomes by gerrymandering, I'm going to do what we call pack the 1L full of L's, and then the L's will lose the rest. In the real world, they call this packing. That is, I want the L's to win only one, right? And the way I'm going to do that is to make one district which is basically full of only L's, or maybe with 1 or 2 D's in there, just depending on how hard it is to draw the lines. Fill one district with only L's, and then the L's, there just won't be enough left over for them to win any of the other districts. So here's what I mean. I'm going to try to grab a whole lot of L's. How about all of these guys? There's 10 there. Maybe I'll take these 2 also. That's 12, 13, 14, 15, 16. You got to have 16 in each one just because I said so. That was part of the setup of this question. So how many is that? I've got 13 so far. I need to take 3 more of these light guys like that. All right? This one is going to be L because it's all L's to begin with. All right? And now you could basically divide up the other 3 more or less however you want. There just aren't enough L's left over for the L's to win any of the other ones. So I'm gonna maybe down here grab all of these guys. That would be 14, 15, 16. How about those 2 also? So like this. All right. You should count and make sure the D's actually win here. We want the D's to win all of the other ones. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 D's in there and 6 L's. So the D's win here. Let me just say that one is packed. All right. You should start with the one that you're trying to pack, and then all of the other ones you can more or less draw however you like. So the D's are going to win this one here. And then I need to divide what's left into 2 more pieces, and probably however I do it, it's going to work fine. This is, I think that's 16 if I just do right like that. And here I have 9 D's in there again, so the D wins that one. And then up here we have some leftovers. There's more D's than L's up there also. All right, so this is an example gerrymander where I made the D's win 3 and the L's only win 1. I hope you can see how doing this in the real world really will make a big difference. Remember, this is a scenario where there is an equal number of voters for each of the 2 parties. So it's sort of in a fair world, it should go 2 and 2. But you can draw the lines in such a way that makes the outcome lopsided so that it's a 3 and 1 rather than a 2 and 2. All right? So that was 3 D's and 1 L's. I would like for you all to try. You should have the paper for those of you just joining us. I got more here. Try to draw districts. This is why I gave you so many different copies here. Draw districts with results of the other 2 possibilities. 2 darks, 2 lights. That one you can more or less sort of guess and check. If you just kind of divide things evenly, you should expect this to be the natural outcome. And then also 1 dark, 3 lights. That one, your strategy should be pack 1 full of darks and then divide up the lights and the rest of them. Anybody else need a paper? Yeah, I'll give them another. I'll give you a moment, and then I'll walk around and see how you feel. Try to avoid making ties inside the districts. I want definitive answers every time. The one B3, we should try to make one that's on all of the dark scores. I'll give you a few more moments, and then we can talk about them. only one D, so I would say pack one district, make it so that it's much more dense.
Yeah, I was trying to get through the comments, but
So there's something, so you could take 9 plus like that. Or you could take 7 naturally. All right, you want to talk about these? There are many, many ways that you could make this work. So probably you did not do it exactly the same way that I'm about to do it, but that's all right. And you will feel, when you're doing these, you'll feel like you're kind of just sort of making it up as you go, and that's true, I suppose. The first one, I saw a few people noticed, actually, the first one, if you divide it up just sort of straight like this, then that happens to magically break down 2 and 2. If you count it up, on the left side, you get 9 darks over here, so this is a dark one. On the right side, you get 10 darks, so the darks win both of those. And then on the bottom, this one has 7 dark here and 9 light, so this is a light. And then on the left, there are 6 darks and 10 lights, so this is a light. So that's the easiest way that you could have done this, although I don't expect that many of you actually did it this way. Really, what I would suggest for doing this one, 2 and 2, an even split, I would say just kind of divide it up in ordinary ways, however you like, and probably it will end up being 2 and 2, because this one is an even split where the voters are evenly split to begin with. All right. Any thoughts about that one? As I was walking around, it seemed like people got something, although not a lot of people did it exactly like this, but that's fine. How about this one over here? So this was a 2 and 2. 2 dark, 2 light. All right, let's try this one over here. 1 dark and 3 light. Remember, my strategy for this is you only want the darks to win one of them. So you should pack the Ds into their own district. Make it so that you have one district which is pretty much all Ds or mostly Ds. And then the idea is there just won't be enough Ds left over to win any of the others. So I'm going to try and look on there and see where I can put a whole bunch of Ds together. And I see something like all of these guys. There's sort of a cluster of the dark ones. Now this is, you got to remember, it has to be 16 in each district. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's 13. Maybe I will additionally take these through. Whoa, sorry. How about I will additionally take those 3? So I had to take 1 light square, but I got 1 light square and 15 dark squares. All right. Now that district right there with the weird shape will be the Ds. And then I'm going to, now there just aren't very many Ds left over for the rest of the picture. And so however you carve out the other 3, probably the Ls will win every time. And hopefully that'll work out. So I will take these 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. How about that? So I'm going to take these guys like this. Just to make sure the L's, I want the L's to win all the, this has 1, 2, 3, 4, 5, 6 D's, which is not enough for the D's to win. So the L's are going to win that one. And then what's remaining, I just divide up, however, in 2 pieces, and probably the L's will win. So it's 1, 2, 3, 4, 5, 6. This is 8, 9, 10, 11, 12, 13, 14, 15, 16. I'll take that much right here. This is L's, and then this one is L's. All right, I hope that seems clear to everybody. Really, the important step was choosing this one first. Right, I made it so that that one is just full of L's, and then there just are not enough, sorry, not that one, the D's. I made the D's first. That one happens to also be full of L's, but that's not how I did it, sorry. This one is what I picked first. Pack those D's first. And then once you pack one of them full of D's, there just aren't enough of the D's to win anywhere else. That's the idea. All right. You can see to get this slightly weird outcome, I had to use a very weird shape. But this is the way it works in the real world too. This is why people in real life politics draw weird shapes. It's to pack voters in certain weird ways. You need to use the weird shapes if you want to do it. All right? Any thoughts about that? I got one more example to try. This is a more, maybe more realistic example. This is a map of our dear university campus. And it has dots on it. So this time I have the two parties are the circles and the stars, right? And I would like to do a similar thing where we're going to try to divide them up in different ways to get different outcomes. So on the homeworks or on our tests or whatever, sometimes I'm going to give you examples which are on grids, and sometimes I will give you examples which are just random shapes, more realistic or less realistic as the case may be. On the homework is one with is a Pikachu shape, so they're not always realistic. The shape really doesn't play much of a role. So, as usual, the questions shall be, first of all, what are the possible outcomes that you can get? And then second of all, can you actually draw the ones which are possible? So, in this case, you could count them all up for yourself, but I will just tell you, there are 50 total voters here. If I'm feeling friendly, I will count them for you and tell you. 50 total voters, and there are 20 stars and 30 O's, stars and circles. Circle, circle, dot, dot. All right, 20 stars and 30 circles. And your goal in this problem, I will always tell you how many districts do I want you to make. In this case, let's make 5 districts with 10 voters each. All right. The total number of voters has to be like divided into a certain number of districts. All right. The first question shall be, what are the possible outcomes? Which outcomes are possible? All right. Remember, this has everything to do with the threshold to win each district. So the way to answer this question, which outcomes are possible, you always have to think of it in terms of the threshold to win a district is, how many people do you need to win in each district? Each district has 10 voters. I said that right here. So how many do you need to win per district?
We need 6.
The answer is 6, yeah. 5 inside of each district. 5 would be a tie, but to win you need 6. So the threshold to win a district is 6 per district. And this will allow you to decide what are the possible outcomes. So for example, for the stars, is it possible that the stars could win 0? Well, yeah, sure. Is it possible the stars can win 1? Yes. Can the stars win 2 or 3 or 4 or 5? Those are more interesting questions. How many can the stars win? Remember I said I just scrolled past it. There are 20 stars and 30 circles. All right. How many can the stars win? Can anybody say what's the most number of districts the stars could win? It takes 6 to win each district. Want to show me the fingers? I see some fingers. The answer is 3. The stars can win 3. You need 6 to win each district. There are 20 of them. If they want to win 3, that requires 18, right? 6 times 3 is 18. And that is possible. But to win 4 would require 6 times 4, which is 24. That's too many. So the question, how many can the stars win? The answer is the stars can win up to 3. All right? This is because 3 requires 3 times 6, which would be 18, which they do have 18, right? They have 20. But 4 requires 4 times 6, which would be 24, which is too many because there aren't that many of the stars. All right, so the most the stars can win is up to 3. And what about the circles? Up to, you want to show me the fingers again? How many can the circles win? I see some people are giving me the whole hand. That's correct. They can win all 5. In theory, the circles could win all 5 of them. You need 6 voters to win each district. 6 times 5 is 30, and they do have 30. So the circles can win up to 5. All right? It is possible for them to win them all. All right. So as for this question, which outcomes are possible? Usually I like to write it in terms of, somebody wins this many, somebody wins this many. The stars can win up to 3. So the possible ones, possibilities, come on now, possibilities are, we could have the 0 stars and 5 O's, right? That's an extreme possibility, but it is mathematically possible. We could also have 1 stars and 4 O's. We could also have 2 stars and 3 O's. We could also have 3 stars and 2 O's. And that's it, because we already said the stars cannot win more than 3. So these are the only possibilities. All right. This first one, in my opinion, seems pretty extreme for the O's to win all of them. Even though the actual breakdown of the population is 30-20, you can actually have the 30s completely blow out the 20s. And then this last one also seems pretty extreme to me. Remember, the population is 30-20, but it's possible actually for the stars to win more than the circles, even though there are actually more circle people than there are star people. You can actually get a sort of a reversed result. Yeah?
Drawing out the districts, do we have to have them all be connected? Because I'm trying to do all the 5 stars right now, and since 9 of them are packed in that one area, it's really hard to do without even giving them one district.
Yes. So, yeah, she's asking, in order to achieve some of these, you will find out when you try to do this in a moment, you're going to have to use some very weird shapes. But the shapes should still be connected. This is in order, like in the real world, this is the rules when you're drawing maps in gerrymandering. Typically, the regions have to be connected. So, the answer is yes, they have to be connected. Try to draw these. All right. I am going to give you some suggestions, perhaps. Like this one here, my suggestion would be pack 1 star district. If you make one district all stars and then the stars will not have enough to win the other districts, that's a typical trick. The very first one, 0 stars and 5 circles, that one, maybe you should do that one last. That one is hard to achieve. But I would suggest for some extreme result like this, I would say make the circles win narrowly every time. But I'll let you see if you can figure it out. You will notice when you look at the picture that I kind of clustered the dots in certain areas. This was not to annoy you. You might think wouldn't it be more realistic if they were kind of like evenly dispersed among each other? Actually, the answer is no, it wouldn't. In the real world, people do in fact live in clusters. For example, something that's true in American politics is that urban areas tend to vote for Democrats more, and people in the country tend to vote for Republicans more. That's another way of saying is just that people do live in clustered areas according to politics. In America, this has a lot to do with race. People live in clustered areas according to race, and it's also true that white people tend to vote Republican and people who are not white tend to vote for Democrats. So there are relationships between all of these things. But anyway, see what you think. I will, again, give you a few minutes, and then we'll chat about it. I would say the 0 and 5 and the 3 and 2 are going to be a little difficult. Maybe try try these two in the middle first. They're a little easier than the other more extreme ones.
Oh, does it have to be on the?
Well, yes. I mean, I would say yes, but that's okay. Doing all right?
I think so.
This one goes down here.
Yeah, it's still typed out right.
Okay. You have to. There's supposed to be 10 letters in each one.
So I should match those together. Okay.
Okay.
Wait, but it's still 3 stars, 10 voters. It's still 3 stars, 10 voters, right? I don't know thoughts.
Getting anywhere?
No, it's just 10 total.
All right. So we got the one that worked.
Well, it depends on which one you do. Like, if you're doing the, like, which one you do
Alright.
now. 2 stars, 3 stars.
It's a little confusing. Yeah. You worked on last time stuff too.
Two of the stars, you played 6.
It might not be helping. You all right? Okay. Draw them short.
I'm gonna wait until like it's drawn out on the
Okay.
It's such a way. Saving the first one. Yeah, so basically that.
I'll give you a couple more minutes and then we can talk about it.
Still good? Did you get the 0 and 5? Alright. So you want to get really 5 circles, they're gonna have to be in 6 in each one. So you have to draw them so that there's always 6 circles and 4 stars. Yeah. It is possible that we can straight sheet. So it's you have to draw 5 regions and choose the side. Or for all of them. So that's it's just like everybody else. You can draw yeah, right. Well, this is good. It's just I would say maybe then into
add a
this
little
one
more.
maybe take some of these eventually.
Yeah.
Still good?
Fix the,
Okay. Yeah. So
that's what it goes on.
oh, so you know.
Yeah.
Oh, all right. You
Does that still work?
yeah.
Can it be like small on it?
Yeah, I mean, in the real world, this would be very suspicious. Like, this is basically disconnected. You just invented a little word that no one mentions. I mean, people do try and do that.
All right, let's talk about these. You do, in order to achieve some of these, you have to draw some very weird shapes, as you noticed. This, this is how they do it in the real world, though. Let's try. I think the easiest one might be this one: 2 stars and 3 circles. That is, in some sense, the most natural one because the actual populations is 20, 30, the stars and circles. So maybe I'll try that one first. I think you can actually look at the map and you'll see that the stars naturally do already kind of exist in 2 clusters. And in the middle there are 10 stars in the middle. So I could put them in a district. And then we also have 10 stars over here. And I could put them in a district. There's actually 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. So I will put these guys together in a district. So those are my 2 stars, and then I can just divide up the circles however you like. There has to be 10 in each one. So I think something like this will do it. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. These guys plus 1 more here, and then all of these guys. All right. So that, I think, is the most sensible way to divide these up. You don't need to use weird shapes at all. This is 2 star and 3 circles. All right. Of course, there are many other ways that you could have achieved that outcome. Any questions about that? I hope you wrote something like that. That was the easy one. Let's try, how about 1 and 4? I will get another copy here. 1 and 4. So I'm going to try 1 star, 4 circles. So for this one, I'm going to pack 1 full of stars, and then the lingo that they use on the streets is packing and cracking. So I'm going to pack 1 star, which maybe I'll do this one here. And then my plan is this other region of stars, I'm going to crack them apart into 4 separate regions in a way so that these guys can't win any of those. So something like this. This is the old pack 'em and crack 'em strategy. Something like that. And then make my 4 regions, including a whole bunch of other circles so that those star guys in the middle can never win any of those districts. All right. This happens a lot in the real world. I showed some examples of real maps last time where like the city of Austin, I believe, is cracked in this way. Austin is like a very liberal city, but actually I think all of their representatives are Republicans. and it's because the city of Austin has been cracked and absorbed into larger Republican areas. Anyway, just to get it straight, I have to actually make 10 in each of these. So I have 3 here, 4, 5, 6, 7, 8, 9, 10. So let's draw the line right there. That's 1. I have 3 here, 4, 5, 6, 7, 8, 9, 10. All right, this is going to be slightly weird, but like that. And then I have 1, 2, I'm looking down here now, 2 here, and then 3, 4, 5, 6, 7, 8, like so. And then finally everybody else, like so. All right, it's the old pack 'em and crack 'em. You pack one, and then the rest of them you split apart into the other districts. Any thoughts about that one? I hope you got something like this. Oh, there does have to be 10. Did I make one that's too small? Which one has 8? Oh, down here? Yeah, I just counted them wrong. Thank you for that. 1, 2, 3, 4, 5, 6, 7. Yeah, there's 7 here. Okay, so they need 3 more. How about that? This is another thing that you will realize as a decent strategy. Sometimes you just sort of draw something, not knowing if it's going to work out or not, and then you can make small adjustments after the fact. All right. How you like me now? Is that all right now? I think this is good now. Thank you for that. All right. So that was 1 and 4. I have 2 more to try. Right? There's 3 and 2 the other way, and 5 and 0. So let's try 3 and 2 the other way. That is 3 stars, 2 circles. All right. This one's going to be weird because remember what's weird about this is there's actually fewer star voters than there are circles, but we can make it so that the stars win more districts. 3 stars. It takes 6 to win. So I'm going to, for example, in the let's look over here. I'll grab 6 of these guys. 1, 2, 3, 4, 5, 6. And put them together with 4 circles. All right. So this is a star district. I'm trying to make the stars win using the minimum possible amount of stars in there. 6 stars plus 4 circles. All right. I'm going to try to do that again. Make another district with 6 stars and 4 circles. Let's take these 4 and then also 2 of these. So this is going to be a little weird, but I'm going to take these 4 circles and 2 of these from over here. Like so. Like that. All right. This is another funny business you can see happening on the map of Texas that I showed last time. You have a region that stretches all the way from one city along a narrow corridor all the way to another city. That's an attempt to grab some people from over here and put them together with some people from over here. It's a similar trick to what I'm doing here. All right, that one also is a star. And now I got to make the stars win 1 more, and that's actually easy. I have plenty of stars left over in the middle. So there's 1, 2, 3, 4, 5, 6, 7, 8 here. I've got to just add 2 circles to all of them. Maybe those 2 circles. All right. So this region in the middle there is also a star district. And now I can just divide the rest, 2 more districts however I want, and the circles will win all the rest. So it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I need 10 circles here, and then 10 circles down here. There you go. All right. I hope it makes sense. Like I said, you need to kind of practice with these a little bit to get a feel for the proper strategies. But the basic strategy would be packing and cracking, and also keep in mind the thresholds to win. So when I was drawing this, I was constantly thinking about, to get my 3 stars, I need 6 stars in each of those 3. That's how I decided to draw these weird shapes over here. All right. And last one is 5 and 0, right? This one perhaps is going to have to be the weirdest, but I want 0 stars, 5 circles. All right. Again, you need to keep in mind the threshold to win. So I'm talking about the circles win every time. In order to win, you need 6 circles. So I'm going to draw it with each of my districts having 6 circles and 4 stars. And you have to do this in a way which still leads to fairly connected regions. So maybe I'll take 4 stars here plus 6 circles here, like so. All right. The stars will win that one. Let's take another district. Again, I want to make 4 stars and 6 circles. So this is going to have to be a little strange. Over here I have 6 stars. I can't take them all because then the stars will win. So I'm going to take only 4 of these. Maybe these 4 here. And then sort of snake around here and get 6 circles. 1, 2, 3, 4, 5, 6. How about that? The worm. Sometimes you got to do the worm. It's all right. This is how they do it in real life. Okay, so I have 4 stars and 6 circles in that one. All right, another one, which is going to have 4 stars and 6 circles. I have 2 stars left over here. I'll pick up 2 from over here, and I got 6 circles in between, something like this. And then, again, 4 stars and 6 circles. I'll take 4 stars from here, like so, and then 6 circles like that. And then my last region is like that. I think I did it. All right. Those ones aren't so weird looking. I guess they are a little weird looking, but this is how it goes. All right. So my strategy here was make 4 star 6 circle in every district.
Wait, no, now you're left with a tie at the last one.
Really? I don't think so.
Oh, what?
I think I have.
Oh, okay, I drew the line.
Yeah. If you're copying down, if you mess it up even slightly, it'll probably be wrong. This particular one has to be arranged in a very specific way. Although you probably did it right, even if yours doesn't look exactly like mine. All right. This is how we draw the lines, okay? If you're keeping track on the checklist, this was number C1 and C2. C1 is determine possible outcomes, and C2 is draw districts to achieve outcomes. That's what we just did. Drawing the districts to achieve the various possible outcomes. All right? Any questions about that? Any thoughts? Great. You'll have some practice with these on the homeworks. I hope it goes all right for you. We got about 15 minutes left. I think we can start talking about the next sort of big thing that we want to talk about in terms of gerrymandering is gerrymandering detection. Gerrymandering detection. Gerrymandering is viewed as a problem in American politics. Some people view it as like the biggest problem ever. Some people will say that this is like the biggest thing that is obstructing American democracy. I'm not sure I would be that extreme about it, but it is viewed as a problem because, as we've seen, when you draw the map in a really weird way, it can cause the results to be distorted from the sort of natural results that you would expect given the amount of people who want to vote one way or the other. So far, in all of these examples, I would say we have been sort of playing the role of the bad guys ourselves, like trying to draw the map in a weird way to achieve a weird outcome. But this is not what we want in our society, right? In our society, we would like to have fair outcomes. What happens then is you have people, like politicians, are going to try to do this in the real world to get unfair outcomes. And it becomes the job of everybody else to try and police that and make sure that there are people are not playing this sort of games. Usually this comes down to the courts. If someone has drawn an unfair map, the only recourse that anybody else has is usually to sue the state or to sue the governor or whoever is in charge of the maps. And then the courts, often the United States Supreme Court, has had to decide whether maps are fair or not. And all of this involves gerrymandering detection. So how can we measure unfair maps? You need, if you're going to argue to a judge or something that this or that map is unfair, you need to actually have something specific that you can say, this is unfair, and I know it's unfair because I measured it in this or that way, all right? And there are a few ways that we can do this. So one is by, actually we're gonna talk about two different ways to measure the fairness of maps. And one, the first one that I wanna talk about is called the efficiency gap. The efficiency gap. And this is sort of a statistical measure of packing. All right? One sort of red flag that there is some kind of funny business going on is if the districts tend to be packed one way or another, because we've already seen that that is a basic strategy to making an unfair map, is by packing the districts full of one party or full of the other party. So the efficiency gap is a specific statistical measure of packing, and you can use this to analyze a map and try to see if that map has been unfairly packed. That's the idea behind the efficiency gap. I decided I have a real world example to show everybody. Here is an example this is an example of something that actually was that went to, I believe, the Supreme Court. This is the Wisconsin State Assembly map. You know, every state has representatives in Washington. Like Connecticut has 4 different representatives. Our district in Connecticut right now is represented by Mr. Jim Himes. But also, every state has their own state representatives. That there's like a separate Congress just for the state of Connecticut, and there's a state Senate, and there's also a state House of Representatives, and you know every state is like that. In Wisconsin, for some reason, they're called the State Assembly. This is the state House of Representatives in the state of Wisconsin, and I will show you the map here. I have it prepared for us to discuss. This is the State Assembly map as of 2018. So this is the map in 2018. Now the colors here represent the Republicans and the Democrats. You can see here, this is typical in American politics. The Republicans are red and the Democrats are blue. And the darkness of the colors corresponds to how close the vote was in those districts. So this light blue one here means the Democrats won, but only by a little bit. All of these light red ones means the Republicans won, but only by a little bit. And the super dark, this like ultra dark blue, if you look at the key here, this is the star here means unopposed. That means that actually the Republicans didn't even run a Republican candidate in this region of the state. All right. What you have here is, like, down here is, I believe this is where Madison is, and this is a little, like, exploded view of that. And over here is Milwaukee, this city. The cities, of course, are divided into their own districts, but something that you will notice immediately if you look at this map is most reds are light red, and most blues are dark blue. All right? What does that suggest to me? It suggests to me that the blues have been packed and the reds have not. All right? Because all of the blue, not all of them, but most of the blue districts are super duper blue, right? They have a super majority of blues. And in many of those cases, the Democrats ran unopposed. That is, these are areas like these districts in Milwaukee. The Republicans have basically said, we're not even going to try to win over there because we packed it so full of Democrats that it's not even worth for us to even try to campaign here. And same goes for over here, and same goes for in here. I don't actually know Wisconsin well enough to say. I believe these blue areas are all sort of cities. which is where the Democrats live, not coincidentally where the black people live. This is all tied up with all that stuff. Anyway, most of the reds are light red, most of the blues are dark blue. This suggests the blues have been packed in order to give the reds an advantage. If you are packing the blues into their own districts, the reason you do that is so that there aren't enough blues in the rest of the districts to win any of them. All right? So this suggests the blues have been packed in order for the reds to win more. All right? And this is the kind of thing that is supposed to be measured by the efficiency gap. It's a way of actually, like if I actually, you don't look at the colors, but if I actually gave you the numbers for all of these districts, you could analyze the numbers and determine that the blues have been packed more than the reds have. And that is a red flag. It doesn't necessarily mean that there's funny business going on here, because in a sense, it is natural for the cities to vote blue. So it's not a surprise that the cities are all blue. It is a bit of a surprise that all the blues that you see here are super dark blue. That is not really a natural thing. Okay, suggests that the blues have been packed in order for reds to win more. Can I tell you about the actual numbers in the state of Wisconsin? So these numbers are from 2018. It has changed a little bit since then, but I'll tell you about that too. So in 2018, 53% of the voters were Democrat and 45% Republican, and a couple left over for, third party or whatever. When it came down to actually deciding all of the these elections, there are 99 different regions in Wisconsin when they do this election. But I will say 63 out of 99 were won by Republicans. So the actual representation is something like 2/3 went to the Republicans, even though there are more Democrats than Republicans who are actually participating in this election. But because of the packing, most of those Democrat votes didn't really matter because they were all sort of voting together in the same districts, and you spread the Republicans out across the rest of them, and the Republicans were able to win far more than the Democrats. I would say more than their fair share, right? Since there were more Democrats than Republicans. I'm not trying to give you my hot takes here. All right. So whatever this strategy of packing the Democrats absolutely worked in this case. Now, there was a court challenge to this map. I believe it went to the U.S. Supreme Court, currently dominated by Republicans. And just last year, the court said, ain't nothing wrong with this map. It can stay exactly the way it is. And in fact, in the latest election in 2022, I believe the Republicans won, I think, 2 more than this. So it actually, the situation from the point of view of the gerrymandering has gotten even slightly worse since then, in terms of the lopsided districts in the state of Wisconsin. All right. Anyway, the way that you can measure this is called the efficiency gap. Actually, this map, I looked up the numbers this morning, has an efficiency gap. People have calculated this statistical measurement, which we are going to learn how to do. This has an efficiency gap of 11% in favor of the Republicans. Basically, what that means is that every Republican vote is sort of counting for 11% more than every Democrat vote is, just because of the way the Democrats have been packed into districts with each other so that their votes kind of get thrown away, or they get wasted, whereas the Republican votes are more effective. This business here basically means that the R votes are about 11% more effective. And this statistic is the worst example in the United States right now. When you measure it according to this efficiency gap, I believe this 11% is viewed as outrageously high. I think a sort of benchmark would be like 5%. Of course, there will always be some kind of natural variation. Something below 5% would be regarded as probably okay, but this 11% is way too high. All right. We are going to talk about computing the efficiency gap. We've only got 5 minutes left, though, so maybe I'll leave that till next time, if that's all right with everybody. If you were not here last time, you didn't get a printed out version of the homework, and I would be happy to give you one right now. If you got buddies or something who never got it, it is on the website like usual. You'll just have to print it out yourself.